In this fourth movie about Newton's laws. In this fourth movie we look at problem solving with Newton. Well, when we have a problem, it could be that all the motion is given. When all the motion is given, well, there will be the question to calculate one or more unknown forces that causes this motion. Well, when we have a uniform acceleration, then we can calculate everything about this uniform acceleration with our kinematical formulas, which we have studied already a long time. And these kinematic formulas will give us a resulting or a net force with second law of Newton. We can have a constant velocity, or we can have an object that is standing still. In that case, we have the formulas for constant velocity, or standing still, which is constant velocity of 0, and then we will have that the net force will be 0. When you have calculated this, we can look at all the other forces and find the missing piece. Because of the net force we now have calculated, we will have an extra force how to solve the problem. We study each axis, x or y, because some of the forces most of the time will be not directly in x or y axis, but at an angle to in respect to one of those axes. And then we need to decompose the vectors or the forces with respect to this frame of reference. For example, you push a shopping cart with a constant force of 200 newtons with an angle of -20 degrees in respect to the ground. The mass of the cart is 45 kilograms. This will cause the cart to accelerate. The pushing force of 200 newtons, will cause the cart to accelerate in 2 seconds from 0 to 2.6 meters per second. Calculate the frictional force and the normal force. Here we have a drawing. You should always start with a drawing. And we have here the mass is 45 kilograms and the pushing force of me is 200 newtons and an angle of -20 degrees. With respect to the y-axis, we know that we have no acceleration. The cart does not start to fly or does not sink into the ground. So, with respect to the y-axis, no acceleration. F res y is 0. With respect to the x-axis, we know that we have a uniform acceleration and we can use our kinematic formulas. We have enough data to solve this problem. We use our speed formula. So this gives us that our acceleration is our speed divided by the time. Initial velocity is 0. So we have 2.6 meters per second divided by 2 gives us an acceleration of 1.3 meters per second square. We can use this in Newton's second law, giving us 45 kilograms times 1.3 meters per second square is 95 newtons is our net resulting force along the x-axis. We make a drawing with the situation. The purple arrow here is the resulting force, and we have all the other forces drawn here. I've got a little vector arrows on top, but I hope you know how to draw them. And so we have our resulting force, and then we have normal force, gravity force, frictional force, and the force with which we push the cart divided or decomposed into pushing force along the x-axis and the pushing force along the y-axis. Pushing force along the x-axis is 200 newtons times the cosinus 20 degrees is 188 newtons. Pushing force along the y-axis is 200 newtons times the sinus 20 degrees is 68 newtons. If you don't know how to do this, I consider you should look up again how to calculate your cosinus and sinus signs in triangular problems. The gravitational force is m times g, a gravitational field strength, so that's 45 times 9.81 or 9.8 depending on where you are, is 4.4 times 10 second power Newton, which is about 440 newtons. Then we have our force in the x-axis, resulting force, 95 newtons. We know that this force here, 95 newtons, that's this purple one, is in fact the green one here. There's the pushing force in the x-axis minus the frictional force here. Because I push this, I need to overcome the frictional force, which gives us this resulting force. And then we can calculate frictional force is equal to the pushing force minus the resulting force in the x-axis gives us 129 newtons. Our resulting force in the y-axis is 0, and so the forces in the y-axis should all end up to 0. Gravitational force plus the pushing force in the y direction minus the normal force should give 0. We worked it out to get the normal force, so that is the gravitational force plus the pushing force in the y direction, and we calculate that gives us about 510 newtons. Another problem could be when the forces are given, but we have to calculate the speed or the acceleration. We have to decompose all forces with respect to y and x-axis. So we have all forces in the x-axis and all forces in the y-axis. And then can give us that in one of those axes, along one of those axes, can it be that we have a resulting force of 0 or a resulting force with an acceleration not 0, so second law of Newton. The constant velocity or no motion is a situation we have when there is no resulting force, and we have our formulas for constant velocity. And with a uniform acceleration, we have our kinematic formulas for a uniform acceleration. An example, you pull the sleigh and on the sleigh is your little sister. You exert a force of 250 newtons with an angle of 30 degrees in respect to the x-axis. The sleigh's mass together with your sister's is 50 kg. The frictional force is 150 newtons and the normal force is 366 newtons. If you pull during 2 seconds, what speed will you obtain if your initial velocity was 0? We have all the forces here, so normal force 366, frictional force 150. I pull, or you pull, on 250 newtons under an angle of 30 degrees, which, when we decompose the vectors, will be 250 times cosinus 30 degrees is 217 newtons in the x direction and 125 newtons in the y direction. The gravitational force is m times g. 50 times 9.81 newtons per kilogram is 491 newton. Forces along the y-axis, so that's the 366, the 125, and in the other direction we have the 491. So 366 upwards, 125 upwards, and 491 downwards, which mounts up to 0. Lucky for us, because the sleigh is still on the ground. Forces along the x-axis, we have the pulling force is 270 newtons, and we have the frictional force is 150 newtons. Ends up to a net resulting force in the along the x-axis to the right of 67 newtons. Then we can use Newton's second law, and this gives us that the resulting force, 76 newtons, divided by the mass of 50 kilograms, gives us an acceleration of 1.3 meters per second square. With this acceleration, we can calculate the velocity with our kinematic formula, which gives us that 1.3 meters per second square times 2 seconds plus 0 initial velocity gives us a speed or velocity of 2.6 meters per second. So, and now I hope you can solve your problems on your own.